In section 8 of chapter 11, we are going to be going over the final trig identity that we are going to be covering in this class. These trig identities are called the sum and difference identities. Again, there are more than just these three sets that I have gone over in this class. There's more than just the reciprocal identities, the Pythagorean identities, and now the sum and difference identities. There are a lot more. This is just a brief little prelude into pre-calculus. Unlike the last lesson, I am not going to show you where these come from, because in order for you to see that, you would need to have more knowledge in pre-calculus. This is typically, if I was to show you all the identities, this is not typically what the next identity I would show you is. The next identity I'd show you either be the double angle or the half angle identity, but this one is used more frequently and allows you to do a lot more stuff with it. So I want to teach this one because it is more important and imperative for your academic mathematical future. Technically, there are 4 identities here. I am going to combine them to only give you 2, but I'm first going to show you all 4 of them individually. Here is your first identity. If you have sine of an angle A plus an angle B, that is equal to sine of the first angle times the cosine of the second angle plus cosine of the first angle times the sine of the second angle. This is our first identity. It is the sum identity for sine. Next, I'm going to show you the difference identity. It starts off the same way. It is sine of A, but now we're going to do subtraction. So we're subtracting an angle B. The order of the trig functions and the angles for this identity is the same as the previous. So it's going to be sine of the angle A times the cosine of the angle B. The big difference is instead of adding the 2, we are now going to be subtracting the 2. So this is 2 of the 4 sum and difference identities. These are the 2 sum and difference identities for the sine function. There's also going to be 2 sum and difference identities for cosine. So the next one we're going to do is cosine of the angle A plus the angle B. Cosine of angle A plus B is going to be equal to cosine of the angle A times cosine of the angle B minus sine of the angle A times sine of the angle B. So that's the sum identity for cosine. Now I'm going to do the difference identity for cosine. So I'm going to go over cosine of the angle A minus the angle B. That will be equal to, again, same trig functions in the same order. Cosine of A, cosine of B, but now it's going to be plus the sine of A times the sine of B. These are the 4 sum and difference identities involving sine and cosine. Technically, there's also a sum and difference identity for tangent, secant, cosecant, and cotangent. However, as you can probably see that these are really complex identities, their variations can be broken down into sine and cosine. So we typically only stick to these 4. However, this is not how I have these identities memorized, because there is a way to take the 2 red identities and blend them into just one identity. There's a way to take the 2 blue identities and blend them into one identity. So here's the way that I blend the sine identities together. Another way of thinking about this is the sine of A plus or minus B is equal to sine of A cos of B plus or minus cos of A sine of B. So if you start with addition inside of a sine function, you're going to have addition in your identity. If you start with subtraction in your sine identity, you're going to deal with subtraction in the identity. And then for cosine, this is the one that looks a little bit weird. If I have cosine of A plus or minus B, that will be equal to the cosine of the angle A times cosine of the angle B. And instead of plus or minus, notice that in the original identities I have above, if you started with the plus sign, cosine of A plus B, cosine of A plus B, the positive got switched to a negative. If you have cosine of A minus B, the negative got switched to a positive. So instead of plus or minus, I am going to write minus plus. That is a way of indicating that the positivity changes. And then the second part remains the same. Sine of A, sine of B. You can either memorize these 4 or memorize these 2. I like memorizing the 2 because 2 things to memorize is easier to do than memorizing 4. I'm going to show you that this works utilizing an angle that we already know from the unit circle. So I have the unit circle up here just as a little reference guide. I'm going to look at the angle 150 degrees. If I was to take the cosine of 150 degrees, I already know the cosine of 150 is going to be negative root 3 over 2. I already know what the answer is. But I'm going to prove that these identities work by running that through those identities. Specifically, I'm going to run it through, not that one, through this one. Because cosine of 150 is equal to cosine of 120 degrees plus 30 degrees. According to the sum and difference identity, if you take the cosine of one angle plus another, it will turn into this. So this is going to be equal to cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And these are all things that are on the unit circle. Cosine of 120, if I just look up 120 on the unit circle, which is right here, the cosine is negative 1/2. So this is equal to negative 1/2 times the cosine of 30, which is root 3 over 2, minus the sine of 120, which is root 3 over 2, times the sine of 30, which is 1/2. This is going to be equal to negative root 3 over 2 minus root 3 over 2. Oh, sorry, not over 2. That's over 4. 2 times 2 is equal to 4, Mr. Silva. And that is equal to negative 2 root 3 over 4. Top and bottom simplify. 2 divided by 4 turns into a 1/2. So this is negative root 3 over 4. And that is the answer right here. Now, some of you might be asking, yay, Mr. Silva, you just showed us a slower way of doing something we've already done. That is not the purpose of these identities. I was showing you an example of something we already knew the answer to. I'm now going to show you how this can be utilized. If I tell you to find the sine of 75 degrees, 75 degrees is not on the unit circle. You can't just look it up. Sure, you can type it into a calculator. A calculator is going to give you a decimal approximation. I don't want an approximation. I want the exact value. Luckily, I can turn a 75 into the sum, or difference, of 2 angles on the unit circle. That is equal to sine of 45 degrees plus 30 degrees. And those 2 angles are on the unit circle. So once I do that and I run that through the sum identity for sine, I will get a new trigonometric expression filled with trig values that I can find. Because according to the identity, that is going to be equal to sine of the first angle times the cosine of the second angle. Now, because I'm dealing with a plus sign here for the sine sum of difference identity, I'm going to deal with the plus sign. And then it'll be cosine of the first angle times the sine of the second. So I just converted the sine of angle 75 degrees, something I do not know, into an expression filled with pieces that I do know, things that I can look up on the unit circle. Sine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2. And sine of 30 degrees is 1/2. That's equal to root 6 over 4 plus root 2 over 2, over 4, which gives me my answer of, actually, I'm going to give myself a little more space for my blue problem. Root 6 plus root 2 all over 4. I have now calculated the sine value of an angle that is not on the unit circle. But Mr. Silva, what if they don't give us an angle that can be broken up into two angles on the unit circle? Well, then you might have to do the sum and difference identity multiple times. I am only going to give you problems that are relatively approachable, just using the identity once. But this can be used to find the sine of 10 degrees. Is it annoying? Yes, absolutely. Is it doable? Also, yes, absolutely. Problem number 2, I have cosine of negative 15 degrees. I've got two options. Option 1, I know negative 15 is not on my unit circle. I could find a coterminal angle with it by adding 360 degrees. That will work. That'll be just fine. Or I could skip that mess and just realize that cosine of negative 15 degrees is just cosine of 30 degrees minus 45 degrees. Both methods will work. This is just faster. It skips one step, finding the coterminal angle. But now I can just use the difference identity for cosine, which is going to be equal to cosine of the first angle times cosine of the second angle. And then we're going to do the opposite of the operation inside of the cosine. So it's going to be plus sine of the first angle, sine of the second angle. All right, now I just look at these things up on the unit circle, or I just internalize and memorize them already. Cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2. Sine of 30 degrees is 1/2. Sine of 45 degrees is root 2 over 2. That's going to give me root 6 over 4 plus root 2 over 4. And what do you know? I got the same answer because these values do, in fact, repeat themselves a lot. Once we start sticking to radians, this is where stuff gets a little bit more tricky. Here is my recommendation. You're always going to have denominators of 12 every single time. You are going to need to split that into two radian measures. I'll deal with addition in this one. You need to have those with denominators of 12. They're both going to have pi. You need to pick numbers that will add to 11. Now, don't just pick any numbers like 10 and 1. You want to pick numbers that will then have each of those fractions reduced to something that is on the unit circle. Remember, our unit circle for radians only has two denominators. It's either pi over 4 or pi over 6. So I want to pick two numbers that add to 11, but then simplify by either being divisible by a number such that the denominators will turn into 3 or 4. So if I pick, for example, what are some numbers that are like that? I can do 8 pi and 3 pi, because 8, if I want to turn that 12 into a 6, or sorry, not into a 6, into a 4, I just take the top and bottom of 8 pi over 12 and divide top and bottom by 4, and that turned into a 3. Actually, I just want to divide it by 2. That'll get me 4 pi over 6. And that's something that is on our unsimplified unit circle. Top and bottom of the second one, I just want to divide the top and bottom by 3. pi over 4. Now I have two radians that are on the unit circle, and I can go through the same rigmarole I did in problems number 1 and 2. Apply the sum and difference identity. In this case, is the sum identity for sine. That'll give me sine of the first angle times the cosine of the second angle plus, because I had a plus sign here, cosine of the first angle times the sine of the second angle. These are all things that are on the unit circle. You could just look them up. Sine of 4 pi over 6. It's 1, 2, 3, 4. So it's 3, 2, 1, 1. So it's 1/2 comma, negative 1/2 comma root 3 over 2. So it's root 3 over 2 times root 2 over 2 plus cosine of 4 pi over 6 is negative 1/2. And then sine of pi over 4 is root 2 over 2. That's going to give me root 6 over 4 minus root 2 over 4, which gives us our final answer of root 6 minus root 2 all over 4. Kind of ran out of space, but you get the gist. And then problem 4 is the annoying one, because now I have a radian measure that is technically not on the unit circle. It is more than one rotation. You can either find a coterminal angle or find two angles on the unit circle that either add or subtract to give you that angle. I'm actually going to find coterminal angles, because all I have to do is, if it's the denominator 12, I just have to add 24, because 24 pi is one full rotation in radians if the denominator is 12. So this is equal to cosine of negative pi over 12, which then is equal to cosine of, what is that going to be? 3 pi over 12 minus 4 pi over 12, which is equal to cosine of pi over 4 minus 2 pi over 6, which I can then run through the difference identity for cosine, which is going to give me cosine of the first angle times cosine of the second angle. We're having a subtraction sign inside of the sum and difference identity, so we're going to use a addition here. That'll be sine of the first angle, sine of the second. Last step, look this stuff up on the unit circle. Cosine of pi over 4 is root 2 over 2. Cosine of 2 pi over 6 is going to be 3, 2, it's 1/2. Sine of pi over 4 is root 2 over 2. And then sine of 2 pi over 6 is root 3 over 2. That's going to give me root 2 over 4 plus root 6 over 4. And surprise, surprise, the answer is root 2 plus root 6 all over 4. It's the same answer we've been kind of circling this entire time.